guys, welcome to Math1141 Algebra. So this time we'll talk about chapter 3, question 78. Next question. Let Pz equal to 3z minus aq plus 5z power 4 plus z power 6. You are told that the 6 roots of P, say alpha 1, alpha 2, until to alpha 6 are distinct, so they are all different roots. Prove that at least 2 of these roots are real. So Pz equals to 3z plus zq plus 5z power 4 plus z6. So clearly z is the root. So we can factorize. We can take out from z. We got this expression. Okay. Now we know z equals 0 is root. We need to find another root which is substituted in 3 minus z squared plus 5zq plus z power 5 equals 0. So we say equation is gz equals to 3 minus zq z2 plus 5zq plus z5. We need to find another z, substitute in this equation and make it equal to 0. Right? So we try 0 first. Obviously we got 3. And we try negative 1. We got 3 minus 1 minus 5 and minus 1, which is minus 4. Right? So we can say alpha 2, another root, is between 0 and 1. So we finish the first part of the question. We prove at least of these roots are, at least 2 of these roots are real. 1 is 0, and 1 is between 0 and negative 1 by the continuity. So now we look at part 2. Alpha 1 plus alpha 2 plus alpha 3 plus alpha 4 plus alpha 5 plus alpha 6 equals 0. So this question is quite straightforward. Some root equals to negative b minus a equals 0. So alpha 1 plus alpha 2 equals to negative b minus a. And we can see b is 0, so it's 0. So part B is quite straightforward. And part C, hence or otherwise, show that there is at least one root with positive real part and another root with negative real part. This part is interesting. So let's look at this question. We do know there is 2 real roots. 1 is 0 and 1 is between 0 and negative 1. Right? So we got another 4 roots. But we also know the coefficient of this Pz equation is real, which means if they got opposite roots, they have to be conjugate of each other. Right? Now we can say there is 6 roots. 1 is 0, 1 is alpha 2, and alpha 3, which is, we say, R1 cs theta. So we say 2 equals to R1 cs negative theta. Right? And we say alpha 5 equals to R2 cs 5, and alpha 6 equals to R2 cs negative 5. And we also know subroot is 0. Right? So we do know 0 plus alpha 2 plus alpha 3 and alpha 4. We got 2 real parts of alpha 3. Right? Because complex number positive conjugate will be twice the real numbers. And plus 2 real alpha 5. Right? Because alpha 5 and alpha 6 is also conjugate. Equal 0. Right? And then we divide both sides, we move alpha 2 to another side and divide by both sides by 2. We do know. Right? And we also know alpha 2 is a negative number. So alpha 2, we can represent alpha 2 as negative absolute alpha 2. In this way, it shows alpha 2 is a negative number. So which is half alpha 2. Right? Now, let's look at this. We know alpha 3 and alpha 4 can't be 0 because we only have one zero solution, which is z equals 0. Right? So alpha 3 and alpha 5 can't be 0. So if alpha 3, real alpha 3 is positive number, which means real alpha 5 is negative number. So we prove the question because they say at least one root with positive real part and at least one root with negative real part. So positive real part, negative real part, or negative real part, positive real part. Why? Because half alpha 2 absolute value have to be positive, and alpha 3 and alpha 5 can be 0. So they have to be one is positive, one is negative. So we prove the part C. How about part D? So now let's look at part D. Show that if z is bigger than 3, then 3z minus z cubed plus 5z power 4 is less than z power 6. Alright, just write it down first. Now, when we look at 3z minus z cubed plus z 5 power 4 modulus, the obvious thing we need to think about is break it down. So, how do we break it down? We can use a triangle inequality, right? So, we can write this as 3z plus z cubed plus 5z power 4. Don't be confused why here is negative and I write positive here. Because by triangle inequality, it have to be pass. So you can't have minus here. If you do, doesn't make sense, right? Now, now let's look at this. What's our strategy? We want to prove z power 6 is bigger than 3z plus z cubed plus 5z power 4. If we prove that, we can prove z power 6 is bigger than 3z minus z cubed plus 5z power 4. Right? So how do we break down z power 6? Z power 6 equals to z squared plus z power 4. Right? And we know z modulus z is bigger than 3. So this is supposed to be bigger than 9. Right? Now we just try to compute 9z power 4 into 3z plus z cubed plus 5z 4. So we got 5z 4 here, so we should have 5z 4 here. Then we got 4z 4 left. And what we need 3z, right? But we have z4, we can write 3z4 plus z4. So this z4 will going to correspond to this z3. So how do we do that? I think you guys should all guess what I'm going to do, which is 3. z4 should be multiplied by 3 cubed multiplied by z. Right? Why? Because this should always be bigger than 3 power 3 multiplied by z. Right? So we can transfer z4 into 3 power z multiplied by z. Plus, same strategy here. We can put 3 z cubed. Right? Because z power 4 we can write z multiplied by z power 3, which is bigger than 3 z power 3. Right? So we just tidy it up, and then we reduce the number of z, reduce the number of modulus z cubed. It should be further smaller. It should be, this is 4, not 2, sorry. 3z plus z cubed. Right? So we match the broke down equation into equation 1. Now we can prove z power 6 is bigger than modulus 3z minus z cubed plus 5z4. Right? Because z power q is bigger than 5z power 4 plus 3z plus z cubed, and 3z minus z cubed plus 5z4 is less than 3z plus z power 3 minus 5z4. So we just successfully proved the question. Now we can go to the last part. Okay, now let's look at part A. Hence, or otherwise, show that for j equals 1 to 6, aj is less or equal to 3. Okay, so when we look at this question, what do we need to do at first? We need to copy down the equation, right? If you have nothing to think about, just copy down the equation. Okay, in this question, they talk about alpha, which is the root of this equation. So we can substitute alpha. So 3 alpha minus alpha cubed plus 5 alpha 4 plus alpha 6 equals 0. Right? And then we can move alpha 6 to another side. Why need to do this? Because from previous question we know z power 6, we got this inequality, and if we want to use this inequality, we need to think about alpha power 6 in terms of another part, right? So we do have alpha power 6 equal to 3 alpha minus alpha cubed plus 5 alpha 4, right? And very obvious thing we need to think is modulus both sides, because in part D they got modulus, so we also should be thinking about modulus. Okay, now when we look at this equation, we should immediately know alpha can't be bigger than 3. Why? Because alpha maybe is a complex number, maybe it's any numbers. But if alpha is bigger than 3, what would happen? We can refer to part A. If z is bigger than 3, then 3z minus z cubed plus 5z power 4 should less than z power 6. So same thing happen here. If alpha is bigger than 3, if modulus alpha is bigger than 3, we will got modulus alpha power 6 bigger than 3 alpha minus alpha cubed plus alpha 4. Right? So if alpha can't be bigger than 3, so modulus alpha or alpha j should less or equal than 3. Right? Just means if we add j here, just means every alpha, right? So every alpha should be less or equal than 3. So we just finish this part, finish the last part of the question.